Hi everybody, and thank you so much for watching this video. So the lesson is, let me see if I can make it better. Okay. The lesson 4.3, graphing linear non-proportional relationships using slope and y-intercept. And the standard is right here. The California Common Core State Standard is 8th grade functions number 4. And you have to be able to construct a function to model a linear relationship between two quantities. Determine the rate of change and initial value of the function from a description of a relationship or from two xy values, including reading these from a table or a graph. And you got to be able to interpret the rate of change and initial value of a linear function in terms of the situation it models and in terms of its graph or a table of values. So remember that the equation that we've been using is y equals mx plus b. This is your slope, and that's the rate of change. That's the same thing as the rate of change. This is your y-intercept. That's the same thing as the initial value, okay? So you got to be able to graph, know right away what's the rate of change, what's the y-intercept, what's the initial value, okay? So it says using slope intercept form to graph a line. Oh, the slope intercept form is this one right here. That's the slope intercept form of an equation. The reason why it's called slope intercept form is because it gives you the slope and the intercept, the y-intercept, okay? So recall that y equals mx plus b is the slope intercept form of an equation of a line. In this form, it is easy to see the slope m and the y-intercept b. So you can use this form to quickly graph a line by plotting the points 0, b and using the slope to find the second point. So for example, number 1, it says graph the equation y equals 2/3 x minus 1. Right away, I know that this is my y-intercept, and right away I know that the 2/3 is my slope. And guess what? I can make a sketch right away. This is going to be my sketch. My y-intercept is -1. Remember, this is your x-axis, this is your y-axis. So it's going to be at -1. This is 0, -1, right there. That's my y. That's going to be my y-intercept right there. Now the slope is 2/3. That means from this point I go up 2. 1, 2 points, and then my run is 3. Remember, 2/3. This is your rise and this is your run. So now I go 3 to the right. 1, 2, 3, right there. 1, 2, 3. That's the other point, and then I just make my line through there, and I'm done graphing it. Okay, this is just a sketch, but you have the real graph right here, okay? So once again, the y-intercept was -1 right there. That's where the line hits the y-axis because that's the point. And then the slope is you go up 2 over 3, 1, 2, 3. Okay, now let's graph, and I'm going to make a simple sketch first. This one, right away, I see this is my y-intercept, okay, +3, and my slope is -5/2. So this is my slope. So I'm going to make a little sketch right here, okay, little sketch. So my y-intercept is 3. This is the y-axis, 1, 2, 3, right there. That's my y-intercept. I put my point. Now my slope is -5/2. So from here I go down 5. 1, 2, 3, 4, 5. And then I go to the right 2. 2, 1, 2, right there. 1, 2 to the right 2. And then I just draw my line through those 2 points. And I'm done. This is my sketch, okay? So, and this is a better graph right here. The y-intercept is at 3. The slope is -5. You go down 5, but this is going by 2. So they go half, 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 because it's going by 2. See? 0, 2, 4, 6. So that's why it looks a little bit different than mine, okay? But you go down 5 and to the right 2, then you make the line through there, okay? Now, the next question, it says, draw conclusions. How can you use the slope of a line to predict the way the line will be slanted? Ooh, the slope, very interesting. Notice this one. This one, the slope was positive, and the slantedness is going up from left to right. It's going up. This one, the slope is -6 See, the slope is negative and the line is going down from left to right, okay? So from left to right, I'm going to put from left to right. If the slope is positive, the line goes up. If the slope is negative, the line goes down. And remember again, positive association and negative association. If the line is going, it has positive association, then it goes up. It's positive, the slope is positive. If the line has negative association, then the slope is negative and it goes down, okay? So right here, it says graph the equation of the line. So here, the y-intercept is 1, so I start at 1, and then my slope is 1/2. I go up 1 over 2 to the right 2, okay? And then I just graph the line right here. This one, the y-intercept is 4. 1, 2, 3, 4 right there. My slope is -3. Oh, it doesn't have a number on the bottom. That means the denominator is 1. So that means I go down 3, 1, 2, 3, and then to the right 1. So then I just graph my line. Okay? So the next question, the next problem, it says example 2. Ken has a weekly goal of burning 240 calories by taking brisk walks. I need to lose calories because I gained so much weight right now that we're at quarantine. But anyways, the equation y equals -300x plus 2,400 represents the number of calories y Ken has left to burn after X amount of hours of walking, which burns 300 calories per hour. Yes, see right here, it says that this one, the slope is negative 300, so that means it burns. You don't gain them. You burn 300 calories, and you start off with 2,400 calories, and then you have to burn. And then it says, what is it? Graph the equation. So once we graph it, and I'm just going to make a simple sketch right here. So I'm going to go by 300s. 300, what is it? 600, 900, 1,200, 1,500, 1,800, 2,100, and 2,400 is going to be right there. So that's my y-intercept, and then I go down 300 and over 1, down 300 and over 1, so it'll be right there, and my sketch is going to be right there. That's just a sketch. But of course, this is a better one right here. Notice they went up to 2,400 because that was the y-intercept, and then they went down 300, or they went down 600, and then over 3. They went down 900 and then over 3, but you could have gone down 300 over 1, down 300 over 1, and right there. Okay, now you're supposed to draw it. Now it says, after how many hours of walking will Ken have 600 calories left to burn? So 600, I just go to the 600 right here, and then I go all the way across to the line, and then I go down, and it says 6 hours. So it's going to take 6 hours, or he's going to have, after 6 hours, he will have only 600 pounds or calories to burn. And you can see it right here on the graph too. Okay. So the question right here, it says, your turn. Ken decides to modify his exercise plans from example 2 by slowing the speed at which he walks. The equation for the modified plan is y equals -200x plus 2,400. Graph the equation. Right away, I see. This is my y-intercept. So I start at that point. Then my slope is -200. It doesn't have a denominator. So I make a 1 as a denominator. So that means you go down, what is it, 200, because this would be 2,000. Yep, Oh, but that's 4. So if I go down 200, I'm only going to go halfway. It's right there. And this is going to be 2. And then I go down another 200. And that's going to be 200. And that's going to be 2 right there. So I go down 400 and I go over 2. And then I go down and then over 2. So it's going to be looking like that. Okay. So does the graph of the new equation, how does this compare to the graph of the other one? Well, they have the same y-intercept, but this one, the rate of change is different. So they have the same y-intercept, which is equal to 2400, but they have different slopes. So when you compare, you say, what do they have in common and what do they have different? The example 2, the slope is negative 300. This one, the slope is negative 200. So this one burns 200 calories per hour. And the other example, Ken, or who was the other one? Before, he was burning 300 calories. Will Ken have to exercise more or less to meet his goal? Well, on this one, he's only burning 200 calories, so he will have to exercise more. He will have to exercise more. And you know what? Right now, my husband and I are exercising together because he needs to lose 30 pounds. I need to lose 15 pounds. He usually runs. So because he needs to lose 30 pounds, so he actually runs and he burns more calories. I don't run because I don't like running, but I walk. So I actually lose less pounds, because I'm only walking. But he got mad. He's like, well, why do I have to walk with you? I need to run. And I said, well, you can run in the morning and then you can walk in the afternoon. That way you can catch up to losing 30 pounds. Well, I only have to lose 15 pounds. Anyways, suppose that Ken decides that instead of walking, he will jog. Ooh, look at that. And that jogging burns 600 calories per hour. How do you think that this would change the graph? So if he runs, then what's going to happen? He's going to burn 600 calories. So that means that the slope will be negative 600. So it's going to be more steep. The line will be more steep. The line will be more steep going down. Okay? Very good question. Okay? So now your job is to finish up all the other questions. Okay? Thank you so much.